So let's consider 5 divide integer division divide by 3 using an integer division, and again the result is a whole number. Definitely we got the answer is 1. So we could rewrite the 5 over 3 as 1 and 2/3, and we are getting in that is 1. Dividing 7 by 3, again it's 2, again it's a whole number. So this would be rewritten as 2 by 2 and a third. So we are only getting the part of the result when we do like this, and part of the result that the divisions. The other part we can get using in the different operator called the remainder operator, or we call this as an mod operator. We use the percentage sign to send these to significantly these operations. So 4 mod 2. So I'm going to get the 4 mod go for mod 2. Definitely I got the answer as 0. There is no remainder for the division of 4 divided by 2. When we divide 2 by mod 2 mod 3, definitely we got the answer as 2. And when we divide 5 by 3, or the 5 mod 3, definitely we got the answer as, again it's a remainder as 2. Now that we have worked with these operations separately, let's combine them into one expressions. We will add 3 to 4 and subtract 5, and when the press answer is 2, apply, the operations are performed from left to right, and the 3 is added with the 4. Definitely we got the answer as 3 plus 4 is 7, and then later 7 minus 5 is 2. Next let's add 4 to 5 and multiply by 3. Definitely we got the answer as 19. That means it is starting with 5 into 3, we got the answer as 15, and later it is added with 4. Definitely we got the answer as 19. In this case, the order of operations dictates that the multiplication should be applied first. Multiplication should be applied first, followed by the addition. The 5 is multiplied by 3, and later it is added with the 4. Definitely we got the answer as 19. So the next expressions we will use a negative number. So this minus sign that we used for subtraction is also we used for the single number in order to mean the negations. We will take the minus 10 and multiply it by 3 and add with 5 and take that to the power of 3, and definitely got the answer as 95. The order of the operations will apply as follows, and 5 will first we take into the power of 3, and because the exponentiation has the highest precedence already seen here, and exponents has the highest precedence, and we will first so we will first take that power of 3, and then over here the negative sign applies to the 10 first, and the result is negative 10 is multiplied by the 3. Definitely we got the answer as 30. Finally these values are combined using the additions. Just like a regular math, we can override the operator precedence using the parentheses. I can have the expressions 4 plus 5 is evaluated as first, and before multiplying the result with 3, definitely I got the answer is 9 into 3. That means the 4 plus 5 has the highest precedence than the multiplications. So I got the answer as 9, and it is later it is multiplied with the 3, and I got the answer as 27. Up to this point, every instruction that we have gave to the Python yielded a result. For example, so when we asked the Python to evaluate the expression 2 plus 3, it gives the result as 5. That's because the expression 2 plus 3 follows the syntax of the Python language. Syntax is the rules that specify which combinations of symbols are legal, and 2 plus 3 is a valid expression in Python. The expression 3 plus with a combination of symbols means 3 plus, it's not a valid syntax because the error with an invalid syntax. So when I asked the Python to evaluate this expression, we got an error. This is our first syntax error, and we will see many more throughout the course. So the Python does not understand what to do with those expression, and with that the combination of the symbols, and it can give us back a result. So instead it gives us an error. Also, if I'm going to give the expression only operation, definitely I got a syntax error. And one more scenario for plus 3, going to use this one, and it is multiplied with the 2. Definitely again I got a syntax error with an unmatched parenthesis. That means if I'm going to use only the closed parenthesis, it shows an syntax error. Instead of this, it would be include an open parenthesis, and I'm going to add 4 plus 5 and into 3. When I am pressing enter, it does not show an error. That means the Python is expecting a closed parenthesis. When I hit an enter, nothing happens, or it look like nothing happens. That's because the Python allows instructions to extend the multiple lines, so that these 3 dots shows the multiple lines extensions, and when we hit an enter, it's waiting actually for a closing parenthesis until I give it I give that the closing parenthesis. I can hit enter, then the expression is not being violated, and after I'm giving that closing parenthesis, definitely it is evaluated and got the result. In addition to syntax errors, we will also encounter semantic arrays. The semantic arrays occur when the meaning of a particular expression is invalid. So for example, the syntax of 2 plus 3 is a valid, and that the above combinations got the answer, and the combination of symbols and its meaning and semantics of that expression is that 2 is added to 3, so this is fine. And if we are going to for divide by 2, again it is a meaning and it has a semantics, and so the expression is correct, or the 4 is divided by is valid syntactically. We are able to use the combination of symbols, and however the meaning of this expression is invalid in the case if I'm going to divide by 4 divided by 0, and definitely it shows an 0 divided by 0 division error, or the division by 0. And we can see that 4 divided by 3 is a valid syntax, so we got the answer. Instead, if I'm going to divide by 3 divided by 0, it shows a 0 error. However, the meaning of this expression is invalid. It's not be possible to divide the number by 0, and so we get a 0 division error, which is a semantic. And here we discuss about the calculation of operation with respect to what Python. We already discussed about the different operators using in the case of Python, and the operator precedence, and also about the understanding with respect to syntax and semantic arrays. Now we exit from this Python and go to the terminal and type Jupyter Notebook for executing the Python program. So we are going to create the new Jupyter Notebook. And here you can see that this is a cell, and we can do the operations and come to the part of expression 2.3, and we can run this each cell and got the answer as 5. And this is quite easy when we use a debugging style of execution of a program. And we are going to use this Jupyter Notebook for the further sessions.